Welcome back to the Akbar Academy podcast. Today, we're talking about a physics concept that's literally everywhere: density. It explains everything from why ice floats to how massive ships stay afloat, and it's way cooler than you think.
You know what blows my mind? The fact that ice floats seems totally normal, but it's actually a bizarre exception to how most substances behave. If it didn't float, life on Earth might not even exist.
That's such a wild way to think about it. And you're absolutely right. Density is one of those things where nature seems to bend its own rules, but always for a reason.
So let's break it down. Density is just mass divided by volume, in other words, how much stuff is packed into a given amount of space.
So if we take something like a cotton ball and a marble that are the same size, the marble feels heavier because it has more mass in the same volume. That's higher density.
Exactly. Scientists even have a symbol for it, the Greek letter rho. We usually measure density in kilograms per meter cubed, or sometimes grams per centimeter cubed for smaller things.
Here's something cool: density naturally creates layers in our world. Think about when you mix oil and water. They separate, right? That's because oil is less dense than water, so it floats on top.
And speaking of water, let's talk about that ice exception. Most substances become more dense when they freeze, but not water. Ice actually expands and becomes less dense.
Which is why it floats. And if it didn't, oceans would freeze from the bottom up, and most sea life wouldn't survive. That thin layer of ice actually insulates the water below, keeping it liquid.
That's one of those beautiful little quirks of physics that helps make life possible.
Totally. And speaking of floating, how about steel ships? It always seems like a contradiction. How do they stay afloat if steel is way more dense than water?
Great question. That's where average density comes in. A steel ship is full of air, so even though the material itself is heavy, the overall density of the entire ship is less than seawater, which is about 1,030 kilogram per meter cubed.
And that's why ships sit lower in the water when fully loaded with cargo. The total density increases, and the ship sinks just enough to stay balanced.
It's amazing how many different densities we encounter. Air is only about 1.3 kilogram per meter cubed, but gold is a whopping 19,300. Even diamond, which feels super heavy, is actually less dense than steel.
And density is constant no matter the size. A tiny gold ring has the same density as a giant gold brick. It's like the material's fingerprint.
Okay, let's switch gears. What about gases? How does density work when something can be compressed?
That's where it gets fun. Gas density depends on both the number of particles and the volume they're in. More particles equals to higher density, or squeeze the same number of particles into a smaller space. Density goes up.
That's why your car tires feel different on a hot day. The particles are more energetic and spread out. So temperature affects gas density and pressure.
Now let's talk about how we measure density. For regular shapes, it's easy. Measure mass and volume, then divide mass by volume. But for weird shaped things, scientists use water displacement.
That's the whole Archimedes in the bathtub moment. You drop an object into water and measure how much the water rises. That tells you the volume.
Exactly. And modern scientists use graduated cylinders for precision. A quick tip: always read the water level at the bottom of the meniscus, that little curve you see at the top.
That kind of precision really matters, especially when you're measuring something like steel, where you want to see exactly 7.9 grams per centimeter cubed, not close enough.
And sometimes you're not using a balance. You're using a force meter, which measures weight, not mass. That means you have to factor in gravity, specifically 9.8 newtons per kilogram on Earth.
Which just shows how connected all these ideas are. You can't talk about density without brushing up against mass, weight, gravity, and force.
Here's something super practical. Scientists use density to identify unknown materials or even test purity. It's like forensic science, but for materials.
So that's how they catch fake gold?
Exactly. Gold has such a unique density that it's really hard to fake. And in industries like food, fuel, or pharmaceuticals, keeping density consistent is key to quality control.
Even in your morning coffee, the way cream swirls through hot coffee is density in action. As the cream warms up, its density changes and those beautiful patterns appear.
It's so cool how something as invisible as density shows up everywhere. From ice cubes in a drink to fish controlling their buoyancy, or why helium balloons rise, it's all about density.
And it's not just in nature. Density is used in ship design, energy storage, material science, and even recycling systems that separate plastics.
That's what makes physics so exciting. Once you understand the basic principles, you start seeing them everywhere.
And honestly, I'm never going to look at my coffee the same way again.
Thanks for joining us on this deep dive into density, from gold bars to clouds, from cream and coffee to the structure of our oceans.
This has been another episode of the Akbar Academy podcast, where science helps us see the extraordinary in the everyday. Because at Akbar Academy, we're a class above the rest.